This is the screencast for section 4.3, example 3. This is going to be the same thing as example 2, so I'm going to go by this a little bit quicker than we did in example 2. As a matter of fact, your book is obviously making things spicy again, because look at the point we're using, -5, 3. In the last example, you used the point +5, 3, so we are throwing in a negative. Look out. But I'm going to start out by drawing a coordinate plane and looking at where the point -5 is, 3. So that's going to be in quadrant 2. And I'm going to create that reference triangle thing that I was telling you guys about before. And I'm going to look at this little reference angle right in here. Again, we're going to get a more specific description of what a reference triangle is in example 4, but for the purposes of example 3, we're going to draw a perpendicular and use the coordinates of this point. So -5, 3, the x coordinate here would be -5, so the distance from the y-axis would be -5, and then the y coordinate would be 3, and then I know this from the last problem, the hypotenuse then would be √34. So here we go. The sine of theta is opposite over hypotenuse, so that will be 3 over √34, and if I multiply both the numerator and denominator by √34, I get 3 √34 over 34. The cosine is going to be adjacent over hypotenuse, which is -5 over √34. Again, I got to multiply both the numerator and denominator by √34. So I get -5 √34 over 34. The tangent of theta is going to be the opposite over hypotenuse, or excuse me, opposite over adjacent. So that would be 3 over -5. Which would be -3/5, -3 over 5, 3 over -5, those are all the same. Cosecant is going to be the reciprocal of sine, so instead of 3 over √34, that's just going to be the square root of 34 over 3, hypotenuse over opposite. Secant is going to be the square root of 34 over -5, the reciprocal of cosine, so hypotenuse over adjacent. And cotangent isn't going to be -3/5, it's going to be -5/3, the reciprocal of tangent, not the opposite and reciprocal, just the reciprocal. Now try problem for example 3 is number 11. We're looking to find the 6 trigonometric functions for theta. If the function is undefined, we'll write undefined. But the point that the terminal ray passes through is 5, -2. So I already drew that out, and I used the Pythagorean theorem to find the hypotenuse of our little right reference triangle here. And the sine of theta is opposite over hypotenuse. So again, we're looking at this little angle smushed in between the x-axis and our terminal ray. So the opposite over hypotenuse would be -2 over √29. Multiply both the numerator and denominator by √29, and I get -2 √29 over 29. The cosine of theta would be the adjacent over hypotenuse, so that would be 5 over √29. Again, rationalizing the denominator, by the way, that's what this is called, I would get 5 √29 over 29. The tangent of theta is opposite over adjacent, so -2/5. And then for cosecant, I can just take the reciprocal of all those. So cosecant would be, I'm sorry, for the other 3, I could take the reciprocal of all those. So cosecant is going to be √29 over 2, the negative of that, because the sine was negative. Secant would be √29 over 5, and then cotangent would be -5 over 2. So once you get the hang of this, the pattern gets a little bit easier. Rationalizing the denominator, getting rid of the square root, that gets a little bit easier. Taking the reciprocals gets a little bit easier. So as you see with practice, these become shorter and shorter problems, even though it seems like you're finding a lot of different things.